Hello, my name is Ayron Gors, and this is my Project 7 presentation for CE570. The goal of this week's project is very similar to last week's, only now we are tasked with verifying the deformed area and deformed volume of some parts of our composite body. And as you can see, I've highlighted the definition of my vector field and deformation map, as you can see, along with the appropriate lines of code within MATLAB. And as you can see, this is deformation map is an exponential function where my structure will be collapsing exponentially, and this will essentially be a snapshot in time of when the structure is failing. Since my body hasn't changed from last week, if you'd like more explanation of my tangent vectors and how I derive them, please see my previous week's project. Now I'd just like to highlight my deformation map and deformation gradient, as you can see here. Taking my deformation map and just adding z1, z2, and z3 to each of those respective locations within that vector, and then replacing those locations within that vector with the appropriate parameterizations of my hollow cylinder and hemisphere, as you can see in my lines of code there, results in all of my work coming out down to these lines of code that is reflected within my MATLAB code itself. And as you can see, I have appropriately defined them as required. Moving on, this is a demonstration of my code. As you can see, I have all the appropriate lines of code defined here within the appropriate locations. I've defined all the given inputs of R1, R2, H, and all that good stuff, and then coded in the map deformation and as well as the deformation gradient, as you can see, for each of my two respective shapes of my hollow hemisphere and hollow cylinder, as well as you can see the definition of my map function. And as shown below, this is the rest of the code. You can see that I haven't hard-coded anything in. It's all working appropriately as it should, so we'll give this a quick run. It takes a rather long time to run because I have a decently large body, as well as just pretty complicated deformation functions. As you can see, this is my output as shown here with all the deformed lines and deformed areas and deformed volumes. And here's the graphs of each of my respective shapes. I chose to go for a deformation of a exponential form. So you can see that's collapsing straight downwards in an exponential fashion. And this is just sort of a snapshot right as it is deforming. In this slide, I'm just highlighting the surface that I'm calculating my deformed area of, which is just the outside surface of my hollow cylinder, as you can see highlighted there, as well as you can see the appropriate lines of code and the deformed structure itself where it's collapsing exponentially. In order to verify the deformed area of my outer surface of my hollow cylinder, I had to first parameterize the surface. As you can see, it's a function of height as well as the angle theta, as the outside radius is fixed at a value of R2. And you can see, just using basic geometry, the undeformed area comes out to be 1507.9645, which exactly matches my MATLAB output, as you can see highlighted there. And then moving on, just plugging in all the appropriate parameterization locations within my deformation map for the different z locations, results in a function, as you can see here. And then finding the area Jacobian through this definition, as you can see right here, and working through all this complicated math results in this very complicated expression, as you can see right here highlighted. And using an online integral tool like Wolfram Alpha, I was able to plug in these different values along with the appropriate values of my radius and my height to calculate a total deformed area of 1206.48, which pretty much exactly matches my MATLAB output, as you can see, resulting in my code working appropriately. Similar as before, in order to verify my volume of my deformed body, I had to parameterize my hollow cylinder itself, which is just the definition of a regular parameterization, as you can see above, with all the appropriate inputs of R1, R2, and H. And then my total undeformed volume is just through geometry results in a value of 2865.1325, which exactly matches my MATLAB output, as you can see below. And then plugging in the appropriate parameterization locations within my deformation map results in this vector, as you can see here. And then finding the volume Jacobian, rather, using this deformation map vector, working through all this math results in this value, as you can see right here. And this is the value that we actually need to integrate across the volume of our total body. And as you can see, I've plugged that into this function, as you can see right here. And then using an online integral tool such as Wolfram Alpha results in a total deformed volume of 2292.16, which exactly matches my MATLAB output, leading to me to believe my code is working exactly as it should be. Here you can see my inputs for my deformed area and deformed volume into the online integral tool, and as you can see, the results exactly match what was defined in MATLAB. Thank you for watching.